So, number one, okay, so you're good? So again, we're gonna demonstrate the Regenex quantum motor, okay? At the upscaled version of what you saw here.
Yep.
We're gonna accelerate the system. We're gonna monitor the input again. Everything that we saw over here applies here. We're gonna bring the system up to rotational equilibrium. We do that every time because we want to ensure the power in the drive shaft is 0 watts, and that the system is neither accelerating nor decelerating. And then we engage either the motor coil or the generator, depending, okay? All right. And this one's, you want some, you know, this is the noisy, this is the noisy one. frequency.
Yeah, gotcha.
It operates exactly like a conventional generator coil.
Okay.
And it performs negative work, which
Gotcha.
you saw.
Yes.
The motor was doing everything that it could to maintain that speed, but the Regen's generator coils, because they were operating below the critical minimum frequency, they were performing like conventional generator coils. Now, just step over here for a sec. Try to turn that rotor with that big thing.
Oh, no.
So it's the same thing that over here,
Yes.
but it's the same experience.
Gotcha.
Now it's relatively easy to turn.
Yeah, yeah. It's harder.
It's much harder. Okay? So what I'm trying to express here, the criteria that dictates regenerative acceleration versus regenerative braking is frequency of operation.
Gotcha.
That's it. Okay? Now, I'll explain why it occurs, if you want.
Sure, why? Explain to me.
If you want to explain, you can go sit down, Peter.
Okay.
So, quick, just briefly, okay? A coil, this is a Regen's coil. Coil is a generator coil, motor coil, it's an inductor, okay? When current flows in the windings, pretty much established. When current flows in the windings, magnetic field, I'm going to say magnetic field energy is created around the coil. Okay? Magnetic field energy is stored around the coil. That magnetic field energy performs negative work in the conventional generator. It performs positive work in the Regen's generator. When it's delayed in the time domain, very important, and the frequency of operation dictates what operation the coil performs, okay?
How are you determining the amount of delay that's necessary to make the,
45 degrees.
thank you, that's all, that's okay.
That's all
good.
you need.
Okay,
That's why we showed it to you.
yeah,
All you need is 45 degrees to reverse the paradigm, but you can go as high as 90.
gotcha.
That's why we showed you.
That's why I was asking.
45 is the minimum, okay? So, 45 to 50 degrees is the minimum. And if you, when you lower the frequency, now the delay goes away. That delay goes away. Why does it go away? Why does the delay happen in the first place? So So this is the equivalent circuit for an inductor,
Yes.
okay? It contains DC resistance, resistance in the winding, inductance in the winding, and parasitic capacitance, okay? When the frequency goes up, when you increase the frequency, in a normal inductor, parasitic capacitance is extremely low, it's negligible, okay? As the frequency goes up, the voltage goes up, what's called the capacitive inductance reactance goes down, the current goes down, the impedance of the coil, that's the AC resistance of the coil, goes down, and the inductance goes up. So basically what happens is as you increase the frequency of a Regenex coil, the Regenex coil begins to operate less and less like an inductor as you approach the critical minimum frequency. As you approach the critical minimum frequency, the coil operates less and less as an inductor, okay? Meaning that the current flowing in the coil becomes less and less and less until the coil ceases to operate as an inductor. That's at the critical minimum frequency. The current in the coil, because of the impedance of the coil, the AC resistance, okay, the current ceases flow. There's no current flow in the coil, but there's voltage being generated in the coil. Above the critical minimum frequency, the inductor starts to store energy in the electrostatic field between the windings as a capacitor, okay? So the Regenex coil, below the critical minimum frequency, which you saw, operates like a normal inductor, performs negative work. Above the critical minimum frequency, the impedance of the coil chokes. An inductor is called a choke. Chokes the current flow. But we're still putting energy, voltage into this. That voltage becomes stored in between the windings. So the inductor stops storing energy as an inductor, storing energy in the electromagnetic field, and starts to store energy internally in the electrostatic field, like a capacitor does. So a capacitor needs time to charge before current can flow in it. Okay? This is where the time delay comes from. When you operate the Regenex coil above the critical minimum frequency, it stores energy in the time domain. It stores energy in the electrostatic field. It stores energy like a capacitor. And as a capacitor, it needs to charge before current can flow. And it takes time for that charge to build up in the capacitor. The windings of the coil are what's called the plates of the capacitor, and the air between the windings is the dielectric, okay? So each winding is a mini capacitor. So the Regenex coil is essentially what's called a multi-parallel plate. You're getting bored, but
No, we're tired.
You're just tired.
Right.
The Regenex coil, when it's operating above the critical minimum frequency, is operating as a multi-parallel plate capacitor, like lots and lots of little capacitors. And this number, the parasitic capacitance, is no longer negligible, it's paramount. It takes over the function of the coil. And it says, current is not flowing through me until I charge up.
Yeah.
And when I charge up, when the voltage in the coil exceeds the capacitor's ability to store it, if you take a capacitor and put too much voltage in it, the current will just flow right through it. It'll just override the ability of the capacitor to impede the current flow, okay? So this has to store, this has to charge up, okay? And you have to wait. A very, very, very small amount of time, but just enough to delay the load current in the time domain. And when you do that, this is what you get. This is why above the critical minimum frequency you get acceleration, because the inductor is storing energy internally, and when you operate below the critical minimum frequency, the inductor is storing energy externally. Like, that is so fucking simple, like, anybody can get it.
Yeah.
It's really, really, really simple. But it's hard when you say, where's the energy coming from to make that system accelerate? That's the impossible leap. But an engineer that comes here is going to see what you saw. The only parameter that we're changing is this number right here, F. And if you change F, everything else changes. And if you took the Regenesis coil and you wound it like a normal coil out of an alternator, it would cease to function. No matter, this is a core out of an alternator, car alternator.
Yeah.
You could run this to 1,000,000 hertz and it would never do what we're getting here. So, and again, when you take this innovation and you put it in an EV, now you have regenerative acceleration, battery recharge, and EV acceleration, and you have regenerative braking. You didn't see that when we did the demo the other day. And you have the quantum motor. So you have all the best attributes, and your EV is starting to charge. We're running this at 3,400 RPM because that's the sweet spot of that motor, okay? When we're operating these two, these are the outputs for the coil, okay? They are not on the switch because I use this with these brushes in order to motorize the coil, okay? So I make the system run as a motor, like without this, okay? So I make coil number 3 act as a motor coil because I want to know how low can I go and still get my motor action, okay, my
Gotcha.
quantum motor action. What's the frequency of operation the minimum frequency of operation? Right now it's like, motor action starts at 500 RPM. So the free motor action, if it's in an EV, starts at, you're not even out the driveway when your coils are now in quantum motor mode. So, and the faster you go, the faster the speed is, the larger the effect is, okay? So, again, when we have it in here, the wheel is turning about 500 RPM, and it's geared down, so the generator is at about 3,000 RPM, and we need 3,000 RPM on these coils to get us into regenerative acceleration mode. Now we can change the parameters of the coil to get that 3,000 RPM down to, in this prototype, you're getting acceleration at 50 RPM.
Okay.
So you can tweak everything,
Yep.
okay, depending on your application. You want to see this before we kick you out?
Absolutely.
It's your demo, man.
I know, I'm watching. I'm here.
Okay?
We're here.
So I need you to come up so you can just check the meters, okay?
Yeah.
All I want you to do, for your sake, you've seen it, okay? I don't want you to take my word for anything here. So, again, the e-bike, I'm going to bring it up to 30 kilometers an hour. This is what you didn't see. You're going to see the coils up the last time. You're going to see the coils operating below the critical minimum frequency, which is regenerative braking, okay? So, I'm going to bring the system up to 30 kilometers an hour.
Okay.
Then, and when this is in an EV, okay, this is going to act like a motor, like a normal motor, okay?
Gotcha.
It's gonna take power from the battery, those coils are gonna help to propel the EV to get it up to speed. That's what we want, okay? Then once it's up to speed, the CPU, depending on what the rider does, okay? If the rider's going up a hill, the CPU is gonna say, those are motor coils. They're not quantum motor coils, they're motor coils. The quantum motor coils are only there to support the motor, okay? They're there to accelerate the system or to add torque without cost, and to reduce the consumption of the original drive motor, as you saw, 220, okay? That's what they're there for. They're not there to eliminate the motor. They're not there to propel. They're an energy-saving device,
Gotcha.
okay? The regen, and then, so here we're in motor mode, okay? Conventional motor mode. Now we're in regenerative acceleration mode,
Okay.
okay? And you're gonna see the current
There.
reflected here. Each time I put on a coil, and we saw 6 amps over here.
Yes.
We're seeing 12 and a half here, was it 12, 13? So we're doubling our output,
Okay.
and and now we're increasing the speed of this big motorcycle motor. Okay, it's not light. It takes a lot of energy to
Yes.
accelerate that. So we're going to show you that. Then we're going to show you the quantum motor coil. Okay, so these are the switches that turn the Regenex coils into quantum motor coils. So we're adding a little bit of acceleration here
Okay.
while we're recharging the batteries.
Yes.
And the more coils we engage, the more acceleration we produce, and the more current we deliver to the batteries, okay? Here, we're strictly using the Regenex coils as quantum motor coils to give us the maximum acceleration
Okay.
or cruising continuation, whatever it is, while, I should say, reducing the consumption of our main drive motor,
Gotcha.
okay? Then, this is the part you didn't see, which we showed over there. We're going to bring the system down to below the critical minimum frequency, okay? And below the critical minimum frequency, 10 or 15 kilometers an hour.
Okay.
When I put these on, it's going to make the e-bike slow down.
Okay.
So you have regenerative acceleration
Yes.
starting at, okay, per coil. Not all the coils, but as many coils as you need, okay? This is one thing that Jonathan grilled me on this morning. The CPU decides what function the coil plays. Is it a motor coil? Receiving power from the battery. Once the CPU decides that motor coil can be converted to a Regenex coil and start sending power back to the battery. Some of them, or all of them, if there's 100 here, could be 10% of the coils. And gradually, as the speed builds up and as the driver lessens his demand on the throttle, maybe 80% of those coils are regenerative acceleration coils, and 20% are motor coils.
Gotcha.
If he's going down a hill, 100% of those coils are generator coils. When he's slowing down, none of them are motor coils. Maybe some of them are Regenex coils, but maybe most of them are regenerative braking coils. The CPU decides the best function for the coil. I'm doing it manually, but this is going to be all automated. Okay?
That's right. Yes.
And road conditions, wind, hills, shit like that, it's going to be factored into the CPU.
100%.
Okay, so the Regenex quantum motor and the Regenex generator, they're
Yes.
not meant to, they're not meant to drive up a hill. That's not what they're meant for. They're meant to give you battery recharge without parasitic deceleration, extended range, and then you go into regenerative braking when you're slowing down, and you're almost pretty much constantly recharging the batteries to some extent, okay? To some degree.
How do you determine the number of coils that you do? Is that just because of the technology, or?
The numbers are, so this is made for 12.
Yes.
It's using 3.
Well, I'm using 5. I think.
5, no, oh, really, okay.
Okay, now, if I had, there's 24 poles on this,
Yes.
it's made for 12 coils, okay? If I had 50 poles, 50 magnets on that rotor,
Yeah.
I can have 25 coils.
Okay, gotcha.
So, everything, it depends on what is it going into,
Yes, and what is going to
what's
do?
the size, how fast, what do you
Yeah.
need, da-da-da-da-da.